Okay, we're going to look at average rates of change, tangent to a curve, slope of a curve. This should all relate to your derivative lab, and normal to a curve, and then speed. The sun is, we're on 2-4, the very first one. We're familiar with average rates of change. Now, average rate of change was on the exam 4 times last year. Well, yeah, and there were some complaints by some of the graders that was on the exam so much, but it's really the whole key to everything we're doing here. It's an average rate of change, and it's easy. It's not, we have to figure that out, but, oh, didn't mean to do that. Okay, think about your average speed, average growth rate for the population, average monthly rainfall. Our average monthly rainfall right now is like 0. I mean, what we're getting right now is 0. The average is much higher. I know we finally got some rain last night, but it's not enough to make up for it. Okay, how do you find your average speed? Now you got to think, don't think this is a math class. I go to Chicago, and here's my time, and here's my distance. In Chicago, I'm going to start off, and I'm going to go maybe a constant speed. I'm going to stop. I put gas in the car, go constant speed, and then I'm going to stop when I get to Chicago. And that's 400 miles. Just to make it easy, it's more than that. And let's say it takes me 8 hours to get there. Well, this is your average rate of change, that secant line. And all it is the change in the distance divided by the change in the time. So what am I averaging for speed? I'm going to go 400 miles in 8 hours. What's my average speed? 50 miles per hour. Okay, I love to travel out west. I do this all the time. Because even though my average speed is 50 miles per hour, is that how fast I'm driving? No. Don't speed in Wisconsin. But I'm probably driving 55 or 60, whatever the speed limit is. Why does the average speed come down? Because someplace I had to stop and get gas for my car. So now I've taken a speed and then actually adding 0 to it. There's a couple ways to find average speed, and there's only one way to do it right now, and it's this way. It's the total distance you travel divided by the total time. It's the slope of the secant line. It does get confusing. If I want my average growth rate, I take the total population divided by the total time. And if I want my average monthly rainfall, I take the total amount of rain in inches divided by the months. Okay, right here, average rate of change is the secant line through the 2 points on the curve. Extend my page. It's just slope. So you've been doing this for a long time. Anytime you drive in your car. Now, as going back to my Chicago trip, I'm averaging 50 miles per hour, but I'm not driving that fast. So what would that be called? That would be called the instantaneous rate of change. And you all do calculus in your car, even though you don't know it. Everybody does calculus. That's your speed at a given time. So if I look down at my speedometer, that's my instantaneous rate of change. So I probably was going 55. Might have been going faster than that. Hard to say. That's your speedometer. So if you drive a car, you do deal with instantaneous rate of change. And actually, I don't know exactly how the speedometer works, but my guess is that they take 2 points really close together and divide by the time really close together, just like you did in the lab. Because you always have to have how many points to calculate a slope? 2. Okay, so this is an instantaneous rate of change. This is a derivative. So we all have derivative machines in our cars. What's a derivative? What did you find out from the lab? A derivative is nothing more than the slope of the what? Of the tangent line. So I could talk about my average velocity on my Chicago graph, any couple points here, or I can talk about it right here. Like if I'm right here, what's my speed right there? I'm stopped. What's my speed? It's 0. That's my instantaneous rate of change. And here is my velocity at that point in time. It changes. Unless you got cruise control, it's going to change. Even with cruise control, sometimes it's not constant. Okay, so an average rate of change is the slope of the secant line. That's all it is. Turning the page, I want to find the average rate of change of this function. Yes. And the derivative is the slope of the tangent line. It's an instantaneous rate of change. So if you're looking at an average, this is the average rate of change. That's secant line, but the instantaneous at this point is just going to be the tangent line. You don't have a way of averaging the velocities yet. That will happen, but not yet. So right now you take your total distance divided by total time. Okay, ready? So let's do a problem. Find the average rate of change of my function over the interval from 1 to 3. And I kind of know what that looks like. Can we graph that without a calculator? Say yes. Yes, we can. Because if I factor this, x, what am I left with? X squared minus 1. And does that factor more? Yeah. X plus 1, x minus 1. So there's my function. Well, first off, I could find f of 0. What's f of 0? 0. It gives me a nice point. I know what cubics look like. And I also have the zeros. So when f of x is 0 is equal to x times x plus 1 times x minus 1. That's what I mean by include a picture of your graphs. Give me a picture of the graph. What does it look like? So where are the zeros? The zeros are at 0, 1, and negative 1. So now I have a pretty good idea what it looks like, because I know cubics look like this, right? I don't have to have a lot of information. I just want to know what it looks like. It goes through 0, 1, and it goes through negative 1. And so it's going to come up like this. It's going to do that. Now you could use your graphing calculator, but there are functions. This would be one that the College Board would expect you to be able to graph without a calculator, because it's not that hard. And I want the average rate of change from 1 to 3. So here's 1 and here's 3. So I want the slope of that secant line. What level of algebra are we in? I want the slope of that line. You're in algebra 1, 2, pre-calc. Slope, where did you first learn slope? Algebra 1. Maybe even in pre-algebra. I don't know. So we did this a long time ago. We should be 100% proficient on slopes. We have to get that. So I just have to find the ordered pair there. So this is 1. What's the y-coordinate at when x is 1? 0. That was easy one. And then I either can put it into the factor one or I can just substitute it in. When x is 3, what's the y value there? It's 3 cubed minus 3. It's what? 24. And I just want to find the slope of the secant line. That's all I'm doing. That's the average rate of change. That's all there is. And we'll say this over and over and over again. So my slope is going to be 24 minus 0 over 3 minus 1. Some of you are going to say, well, I can do that in my head. You're right. I can do it in my head too. However, on the exam, if you don't show them the slope points that you put in, the coordinates you put in, you will not get the point for the slope, even if you do it right, even if it's only 1 point. I'm just warning you right now, you got to show what you're thinking. Because there's no way for them to know that you were really thinking about it correctly. You could have just gotten lucky. And that happens, by the way. So this is 24 divided by 2, which is 12. That's my average rate of change. That's not too bad, is it? Nothing but slope, yes. Yes, because I don't have any units. And on the exam, they'll say include units or they won't. If they say, they don't say anything about including units, then just don't worry about it. Well, yeah, it depends on the question. We'll do more, but this was an average rate of change. Can I find an instantaneous rate of change? Yeah. Okay, so that's not too bad. So make sure you read the question correctly. And so let's do problem 2. And I don't have the picture. I could get the picture, but I don't really care. It says using the points. What is Drosophila? Anybody know in biology? I have no idea either. But this is an application problem, and that's how they're going to give you on the exam. But I don't care what the whatever that is. It doesn't matter. It says use the points 23, 150, 35, 340. And I don't know what the graph looks like, but I don't really care. Compute the average rate of change and the slope of the secant line. Those are the same things. So what's your slope? Now, when I do slope, especially if I'm dealing with negative numbers, I would put the parentheses in. I call them magic parentheses, but I think I'm going to call them invisible parentheses instead. What? Oh, it's a fruit fly. Okay. So this must be the population or something. Right. So it's the change in the population over the change in the time. That's your average rate of change of the population. It's just an average. How fast are they growing? So what do you want to put in here? Doesn't make any difference. You want to put 340 in here? And then what goes here? 150 and 45 and 23. And by the way, if that's the question, you don't have to finish subtracting to get your point. You get your point right there. You don't have to do the arithmetic. Right. And if you do the arithmetic wrong, you lose the point. So we don't want to do that either. So I'm just going to leave it because I don't care. But it might bother some of you. But if you want to know what it means, if you had to interpret it, I might have to do the subtraction. But I tend to not borrow very well. So I make errors in my subtraction. Well, that's the average rate of change, and that's the slope of the secant line through PQ. That's all it is. It doesn't tell you what's happening at an instant. It's telling you between time 23 minutes and 45 minutes, that's how fast that population's changing on the average. Okay. That's it. So we can think of average rate of change as the slope of the secant line. What if we wanted to find out how fast the population is growing on a day, on day 23? We could pick points closer and closer together on the curve. So maybe it looks like this. And I'm going to pick a point here. Maybe I'll make it a green dot. And here. I'm going to keep this one fixed. And I'm just going to drag that point down. I want to get it closer and closer and closer. Didn't we do that in the lab? Yes. It closer, so close that I could maybe draw a segment that goes through there, and that would give me my instantaneous rate of change. That's the tangent line. So this is the instantaneous. I need to find an abbreviation for that. Yeah. I hate writing that word. So what we're doing at 2-4 is exactly what you did in the lab. And so let's draw the picture. I have the picture here. I don't have the picture here. I have it written down, but let's draw the picture. So here's my function. This is f of x. And now I want you to do this with me. Here's the point I'm going to anchor down. That's C. And I'm going to go over here and pick another point. And let's call the distance. Oh, I didn't want to do that. Let's call the distance between this point. This length is h. I'm hoping I'm going to be answering some of these questions still in the lab. Then where am I on the x-axis here? If this is c plus h. Okay, this is a derivative. It's a definition. We will find easier ways to do this. So then what's this ordered pair? This is c, comma, not y. What's my function? F of c. And then this is c plus h. What's the y value? F of c plus h. Should look familiar. And if I wanted to find the secant line, let's just do this in general, the slope of the secant is just the slope between those 2 points. Well, we know how to calculate that. It's the change in the y values. So it's f of c plus h minus the other y value, which is f of c, all divided by the difference in the x values, which is c plus h minus c. Then when I do the parentheses, you see slope a lot easier, or more easily, I think. And what happens in the denominator? What happens to c's? They cancel out. I don't see slope very easily when I look at this formula. I do now, because I've been doing this for 20 years. But initially, I didn't necessarily see slope there. And that's what you have to remember. That's all a derivative is slope, but between 2 points infinitely close together. So this is the average rate of change. And now what am I going to do to get the instantaneous? I'm going to take this point up here, and I'm going to try. There it goes. I'm going to drag it closer and closer. What's happening to h? It's going to what? So that's the limiting value. So an instantaneous rate of change is taking my slope of my secant line and taking the limit of it. That's all it is. Then we take f of c plus h minus f of c all over h. And I'm going to let h go to 0. Why did we do all the work on limits? This is why. If you remember that worksheet, we had to do something like f of c plus h minus f of c over h. It was the last two problems on the worksheet. We did x squared and we did x cubed. To remember. There was reasons for that, because now we're going to do this. Okay, that's all there is. Average is just the slope. Instantaneous is taking the limit of the slope. Does that make sense? Okay. Now the fun part. Let's do some problems. This part you're not going to like, because this is the algebra. I love the algebra, but you guys don't. But there it is. Instantaneous rate of change. Now what you're going to do on the exam, I have not seen them ask for the definition of a derivative on the exam in a long time. They used to have you do problems using the definition of a derivative. They could always do that on a free response question. More than that is they're going to give you a derivative. You're going to have to recognize, oh, that's a derivative. I know another way. You don't know the other way yet. In 3-3 you will. But you're going to find another way to do this, and you're going to do it the easy way because you won't have time. Like when you did the sign of pi plus h. That took a little bit of work because you had to know an identity, right? So all I want is the slope of the tangent line. Let me do a quick sketch. I could bring up my calculator if you wanted me to. So here's y equals x squared. And at 2, 4, so right there. And then I want the equation of the tangent line. Well, let me first do the equation of the tangent line, because that's what I like to do first, because that's easy. If I don't know what to do, I'm going to start with what I do know what to do. What's the equation of a line? And it better be point slope. Y minus y1 equals m x minus x1. You guys know where that formula comes from, right? Or don't you? Because the slope is the change in y over the change in x. And then what would I do to that equation? I would cross multiply. So that's a much easier way to remember than y equals mx plus b. It's a much more natural way, actually. So now I'm going to do what I know how to do first. What's the y value? Whoops, I don't want x1 there. What's the y value of my point that I'm going to put in there? They were nice. They gave it to me. That's 4. Is it easy to turn these around? Yes, it is. And x is 2. And so the only thing I need to figure out what is the slope. That's it. So how do I find the slope of the tangent line? I have to use this formula right here. Now, I either can do it with c in there, or I can do it with a 2 in there. So let's do it. Oh, please don't be joined. Oh, it is. Let's do it with the 2 in there first. So I'm going to have to scroll down here because I don't have enough room. So it's the limit as h goes to 0. I'm going to write the definition right here. C plus h minus f of c all over h. That's how you find the slope. Okay, and f of x is equal to x squared. And what's my c value? Where am I finding this instantaneous rate of change? At 2, right? That make sense? The slope's going to be changing as I go around the curve. So it's the limit as h goes to 0. So it's going to be f of 2 plus h. I'm going to set this all up. I would go right to the formula, but I'm going to do this, all of it. F of 2 all over h. And so in place of x, you're going to put in 2 plus h. So it's the limit as h goes to 0. Okay, so it's x squared. So my x is 2 plus h. This is what goes in for x. If you have questions on that, you need to come and get some extra help with that. Okay. So I'm going to get 2 plus h quantity squared minus, and then what I'm going to put in for x. We've done this problem before. And then what do you have to do? If I substitute 0 in, I get 0 over 0, which is what I always should do first, because then that tells me there's a hole. There's going to be a factor there. What I like about math is it tells me what to do. I should do what with 2 plus h? Multiply it out. Can't factor it. Multiply it. What is that going to give you? 4 plus 4h, don't forget the middle term, plus h squared minus 4. And I promised you that this number here is always going to cancel. Always. So if I did it wrong, it's going to show. Okay, so it's the limit as h goes to 0, and I get 4h plus h squared. This is still algebra. And you guys like me to factor out the h. So I'm left with 4 plus h. Did I do that right? And there's the whole. Okay, so as long as I'm not at 0, because I don't remember, I don't care what happens when h is 0. That's not unimportant. But h is going to be really super close to 0. In effect, I can put in 0 there. And what's the limit? It's what? 4. And so that's what I'll put in way back here. M equals 4. Now, the algebra gets to take you some time. But it's not that hard. You really should, because sometimes on the exam, they won't give you the point unless you do that. I ran into that my very first year of grading. I have to have it as multiplied, so yes, I cancel it right here. I can't cancel it here. It has to go into both. It's really 1 over h times 4h plus h squared using derivative property. Okay. What if I do this at C? What if I do this? Instead of doing it at 2, because that's only 1 point. There's an infinite number of points. What if I asked you to find the slope at 2, 3, 4, 5? I don't want to do this a whole bunch of times. So why don't I just do C plus h? And maybe I can squish it in here. If I write small, I can. So it's the limit as h goes to 0. And I'm going to put in not 2 plus h, but c plus h. Does this look familiar? Minus, what am I going to put in for x? C all over h. And again, I don't know what to do. If I put in 0, I get 0 over 0. So why don't I just multiply that out? And we did this on a problem. And if you remember, I said the answer would be 2c. Because I can look at it, and you will be able to do that too when we get there. So it's c squared plus what? Middle term. 2ch plus h squared minus c squared all over h. What's going to cancel? And then either I can divide the h out into every term, or I can factor an h. And I'm left with 2c plus h all over h. Now what happens to the h's? Now I can cancel. Has to be multiplication. And when I substitute h equal to 0 in there, I get 2. I get a formula. So if c is 2, my answer is 4. But what if c is 3? My answer is 6. And you can see that what happens to the slope as you go around your curve. What happens to the slope here? It gets steeper, doesn't it? What's the slope at the bottom? It's 0. So we're going to be using that to find maximum and minimum values of our function. Its slope is 0 at that instant. As you get closer and closer, you can see it's getting closer to 0 from both sides. And it has to be a smooth transition. I'm really kind of answering another question. It can't abruptly change. It is going to go from negative to positive, but it's got to go through that 0. It's got to be 0 there. It's the same as if you are backing up your car and you're in reverse, and now you want to go forward. You have to stop the car before you shift into drive. Because if you don't, you wreck your transmission. Or, in my case, because I have a manual, I grind a few gears. It's not a good thing to do. You have to stop. So for a derivative to exist, it has to be a nice, smooth transition. So think about your lab. There are some places where it wasn't a nice, smooth transition. And be careful because the calculator lies. Oh, we've got the formula here. It says find the equation for the tangent of the curve at these 2 points. Now, remember what the formula was? And remember what the symbol for derivative is? I should go back. We call it f prime of c. What was that equal to? Because I did it once, I don't want to do it again. I'm too lazy. What's the derivative? It's 2 times the x coordinate. So it's 2c. So what's f prime of, what's my x value on my first ordered pair? What's x? Negative 1/2. So what's that? That's going to be 2 times negative 1/2, which is negative 1. What about f prime of this other one? 1. And you're going to have to do this on the test. This is as low level as it gets, right, in the equation of a tangent line. So this is going to be 2 times 1, which is 2. So those are your 2 slopes. Can you write the equations of those lines? It's y minus y1 equals the slope x minus x1. So doing the first one, it's y minus, what's the y value for my first point? 1/4. What was the slope there? Negative 1. X minus a negative 1/2. Do I need to simplify that? Only if it's multiple choice, you have to worry about it because you have to match. What's the equation for the other one? It's y minus, it went through 1, 1, and the slope was 2. What's the equation for that line? Should go quick, quick, quick. Equals 2x minus 1. Just leave it. Don't multiply it. Because if you multiply it wrong, you're gonna lose your point. Just leave it. You never have to simplify anything. You don't have to simplify the sine of 30 degrees. You can leave it the sine of 30 degrees. You'll get full points. That's going to be the hardest thing for you to do, is to leave your answers, because you're so used to being made to simplify. But you will have to do that on the multiple choice part of the test. So it's not too bad. All you have to do is do that limit to get the slope. I guarantee you will have several questions on the exam that ask you for equations of lines. And this is all you do. Okay, we're almost done. Then tomorrow, you hopefully try your homework. And yeah, we are almost done. And bring in questions. Tomorrow you'll have work time. So what's the slope of PQ? I'm finding the average rate of change. Well, let's put a point on here. What would you like to call this? Do you want to call it star, or do you want to call it a letter? Don't use X. T?
T for Tom.
Works. This is H. Then this is T plus H. Okay? So, what's the average rate of change? What's this ordered pair here? It's t comma what? F of t. They're dummy variables. It makes no difference. T plus h and f of t plus h. Can you write the slope? I'll give you a chance to write the slope. Somebody want to come up here and write it up here? And then the slope of the tangent line. Sure. It's for Halloween.
Okay, so this one.
Yeah, just do the average rate of change.
Right.
Then we'll do one that's hard to do algebraically. We can do it.
But you can.
Let's see. Say that.
Alright. Stop hating. Hate on me, baby. Now
Oopsie. No, it's not going to work. That time. Okay, that's close enough. Okay, who wants to write the slope of the tangent line? This is even easier. She did the work. Well, we did it at C, but we'll do it at T. Because we made it T. Come on.
Holy Hannah. What do I want? Tell me what you want.
Oh, it's you.
Okay.
I have like a bag in my house. We came in like. Oh boy.
All right.
Yeah, perfect. That's C or T or A, it doesn't matter.
The girls are wrong. Like in the equation, your age, please. Oh, where do I get my hands?
Right up here. Let me pick out something. Okay, let's do another one. Maybe have you guys do some more. Okay. Okay, this one's trickier. No, by the way, I did this one with an Inspire graph. I think they're nicer graphs than the 84. Find the slope of the curve at x equals a. Okay? So what's that ordered pair? That's a, f of a, and then we're going to move over to some h value, so it's a plus h, f of a plus h. Well, what's f of a? If f of x is equal to 1 over x, then what's f of a? 1 over a. It's okay. So far, so good. What's f of a plus h? 1 over a plus h. Okay, somebody want to write up there what that slope is?
How much do it?
We will get the instantaneous. Let's just find the slope of the secant first. This is not hard. This is first year algebra, you guys. Come on. I'll help you with the algebra. Nobody's brave enough to do this, huh? I just want the slope between these 2 points.
You just have to find slow time.
Yes, you do.